Hello everybody, welcome back to our final video of this unit, Unit 3, Lesson 8. I know it's going to be a long, exhausting day for you to watch all 4 of my video, but right now this is going to be the last one. You got this, okay? Okay, so in this last exit ticket is going to be a combination of everything that we have learned, and actually is combination of exit ticket 3 and 6, I think. And all of these are actually testing your knowledge about how can you actually find a number with limited information. So let's take a look at this. And this question says in 1966, Miami boy smuggled 3 giant African land snails into the country. So 3, no matter what it is, circle all the numbers first, okay? And based on this story, we know that this is going to be our initial because you have 3 snails at the beginning. So his grandmother eventually released them into the garden, and 7 years later, okay, so in 7 years, there are approximately 18,000 of them. So this is scenario number 1. This is going to be one pair of good info. One pair of good info to actually help you to find a rate, right? The snails are very destructive and have to be eradicated. That means to eliminate or be killed. And it took 10 years and cost 1 million to eradicate them. So just circle them. All of the useful information will be used later. Okay, assuming the snail population grow exponentially. So far, luckily, it talk about exponentially, but not compound or compound continuous. So that means our equation would be just like ABT, and that's it. Very simple ABT. It says write an expression in the form P, so that means we'll have P equal to ABT, something like this, in terms of the time number T in years. Okay, so label this as have to be in years. Okay, so unit is very important. Just don't forget unit is very important. So let's use whatever we have. We have one scenario, we have one initial, and we don't know the rate yet. So just like our lesson, I think it's lesson 2. Well, actually, lesson 3, sorry. I was correct. In lesson 3. Now, we actually have one scenario and we have to find that, r equal to something first. And then we have to plug it in back in so that we can find the other information. So again, in here, we have to go ahead and find out the rate first. Okay, so by using our known scenario, I have 1A000 equal to my initial, which is actually just 3 of them. And the rate at I don't know, and it's 7 years. Again, it mentioned the units in years, so I'm not going to change the 7. So in here, first thing, this is a 3 times r to the 7. So I have to divide by 3 on both sides. I got 6,000. And then r to the 7 power. Okay, just like the previous lesson, not the previous one, sorry, the lesson 3, which is a previous video, we have cube root is going to be applying to the cube, and then square root to be applied for the square. And then right here, I got 7 power. So that means I gotta have a 7 root. So 7 root for the 6,000, and now I have an r. This is going to be our rate. And then if you decided to round it, you decided not to round it, it's going to be fine because this is not your final answer. This is just a very good indicating for the number that is going to be not easy to round. So I decided not to. But if you want to, this is actually around to be 3.46526 if you're a person who will love to round it. Okay, so I'm going to actually write it in the equations that P equal to A. What's my A? It's just a 3. What's my B? I prefer writing it into a exponential, into a 7 root form. And then I'm going to keep this, and then I'll put a T right there. So based on this, I have a complete equation. Okay, let's take a look at the second question. It says, right, that how long would it take to double? Now, in the previous video, in the previous video, one of them actually talked about how long would it take to double. But the thing is, I did not know my initial back then. But right now I know. So actually, I can change it to some regular number that I can use. And in here is initial is a 3. And what is double? Double 3 is just number 6, right? So right here, I got a 6 equal my initial, which is going to be a 3. I still don't know that what is this going to be. I still don't know what's the t going to be. So I'm going to copy whatever that is and then try to solve for t step by step. Okay, so first thing, I got to get rid of the 3. So I divide by 3 on both sides. I got a 2 and 7 root of the 6,000, parentheses with this t power. Now, base, power, constant answer. So I can actually use a log. So t, which is our power, is going to be equal to log base and then answer constant. So in here, you are actually gonna get an answer. After you punch in calculator, by the way. After you punch in calculator, you get a 0.557735 year. So I would say about half of a year, or about like 2 seasons, 6 months, something like that. Okay, the last one is assuming the cost of the eradicating snails is proportional to the population and assume it does not grow starting the day we start eradicating process. So back in the question right here, 10 years and 1 million. In here, pretend we actually have all of this and it's happened after 7 years, right? Oh, after 6 years. So that means we actually need to find out the population for 6 years. And right here, 10 years is, let's take a look at this. So if we have 18,000 and 18,000 of them to be eliminated within 10 years. So that means approximately, let's actually write a ratio first. 10 years, 1 million, and then 18,000 snails. So that means if I'm actually dividing by 10, so that means 1 year, I can spend 0.1 million, or maybe you can translate into other different unit, that's fine. And then 1,800 snails. Pretend this is going to be an eradicating process is actually just a linear function. This is how you actually find a ratio. But we actually need to find out how many are there in 6 years first, right? So let me use the same equation. 7, 6,000, and then I need to plug in 6. After you punch in the calculator, you actually got 5194.40978. And then again, living organism, you have to round down. So I'm going to say 5194 snails. Okay. And then every 1 million is going to be for 18,000 snails. So I actually need to have a conversion for it. So that means I need to times 1 million per 18,000 snails, right? So that means after you use 5194 times 1 million to divide by 18,000, you actually have 288,578.3211. So 288,578.211. So this is actually how you find it. Again, because right here it says like assume that we actually don't have the growth after the eradicating process. But if we actually have a eradicating process happening at the same time while the growth is still happening, that's going to be a very complicated question for us to calculate. Okay, so it also like would be a very crazy money to spend on. Okay, so that's it for the unit 3. Everybody, good luck studying. Make sure that you watch every single video. I know that I said it. Please rewatch it. If you need extra help, please come to office hour. I know our exam actually happening on the next Wednesday, which is not going to have enough time. So make sure you rewatch this video. A lot of them is going to be very similar happening in the exam. So good luck studying and come to office hour if you need to, okay?